Hello everyone. This is graded assignment 8. In this week, we have to integrate data poisoning for the iris pipeline, which we were using in the past weeks. And we have to randomly generate numbers at various levels, 5%, 10%, 50%, and explain the validation outcomes when trained on such data. So let's go to the GCP. So as you can see over here, I have created a file Python poison data.py. So this script stimulates a data poisoning attack by loading the clean iris dataset and replacing the feature values in a random subset of rows. For example, 5%, 10%, and 50% with uniformly distributed random numbers. Basically, this script serves as a tool for security testing by generating a poison dataset. It allows us to evaluate a model's robustness and the effectiveness of our validation methods by training on intentionally corrupted data. So as you can see over here from the previous week, I have already iris prepared.csv. So let's go. I will first clean this. Okay. So now first I will do python train.py and see the metric. As you can see, the accuracy of the decision tree is 88.5%. So now I will corrupt the data to 5% using the poison data.py which I have created. So I will copy this and paste it over here. Okay. So as you can see over here, I have received one iris poison 5.csv. So it has corrupted the data set at various entries. So let's go to the terminal. So it says that poisoning 7 out of 152 rows, which is the 5%. So now I will do the training on this poison data. So as you can observe that the accuracy of the decision tree now is 85.2%, which has decreased from 88%. Now uh, let's do 10% poisoning. So it now says poisoning 15 out of 152 rows. And let's train the data on this. Okay. Now there is no significant in decrease in this accuracy. We will do 50% poisoning and see. So 76 out of 150 rows has been poisoned. Now let's train on this 50% poison data. So as you can see, the accuracy of the decision tree has decreased to 65.6%, which is a drastic decline in the accuracy. So uh, what happens is in the baseline, which is 0% poisoning, the model achieves high accuracy. The model is learning from distinct patterns from the clean data. The decision boundaries it creates effectively separates three iris species. Okay, so when we do 5% poisoning, the model's training process is now influenced by a small number of nonsensical data points. These random outliers begin to pull and wrap the decision boundaries. While the model is still largely correct, its availability to generalize is weakened, leading to more misclassification. And when we do 50% of the poisoning data. Accuracy is now catastrophic, dropping to nearly random chance for a three-class problem. Randomly guessing would yield 33% accuracy. The dataset is now half signal and half random noise. It is impossible for the model to learn any meaningful pattern. The feature have lost their predictive power, and the model's performance is no better than making a random guess. So, to sum this up, and how we can mitigate data poisoning attacks is first pre-training, like input validation, rule-based filtering. We can reject the data that violates domain knowledge, that is petal width cannot be negative or outside a realistic range. And we can do outlier detection. We can use unsupervised algorithms to automatically identify and quarantine statistically improbable data points before training. And we can also do data drift detection to monitor the statistical distributions like mean and variance. And secondly, while doing training, we can do ensemble methods and regularization. And we can also do post-training MLOps governance like data provenance and immutable data sets and live model monitoring to mitigate this kind of poisoning of the data. That's all for this week. Thank you.